Hello students, good morning and welcome to your beautiful channel that is 33.physics for you. Now in this video lecture we are going to discuss about energy of satellite. Energy of orbiting satellite. Now when a satellite is orbiting around Earth, the necessary centripetal force is provided by gravitational force of attraction. Suppose if we consider Earth over here, let us say okay, this is Earth having mass me. Let mass of Earth be me and radius of Earth be re. So from center to this position, this distance is radius of Earth re. Suppose a satellite is orbiting around Earth. Somewhere over here. Let us say mass of satellite is me and it is at a height h from the surface of Earth. It is at a height h from the surface of Earth. Or you can say that the total distance from the center of Earth to the satellite is r, which is equal to here r, which is equal to re plus h. Re plus h. Okay, now whenever a satellite is orbiting around Earth, the necessary centripetal force is provided by the gravitational force of attraction. So you can write here the necessary centripetal force required for orbital motion is provided by Now, whenever an object is performing a circular motion or an orbital motion, some force will always be required, right? Which we call as centripetal force. So, this centripetal force will be different in different cases. In case when satellite is revolving around Earth, it is gravitational force. In the same way, when an electron is revolving around a nucleus, then in that case, electrostatic force of attraction is responsible between proton and the electron, right? So in this case, the necessary centripetal force is provided by gravitational force. Now we know that centripetal force, let us write Fc centripetal force is equal to Fg gravitational force. Now what is centripetal force? The formula for centripetal force is mv0 square by r. Here V0 is known as orbital velocity of satellite. So here what you should write, let mass of Earth be me, radius of Earth be re, and satellite of mass m is orbiting around Earth in an orbit of radius r, where r is re plus h. Let the orbital speed of satellite be V0. Satellite is moving in this direction with speed V0 is equal to, what is formula for gravitational force? G-M-E-M over r square. So this m and m will get cancelled out, r and 1 r will get cancelled out. So we'll get formula for orbital velocity V0 square will be equal to G-M-E over r. So clearly you can see that orbital speed is independent of mass of satellite, because mass of satellite here gets cancelled out. So the orbital speed of satellite is independent of mass of satellite. It depends only on the distance. So orbital speed is inversely proportional to root of distance of the satellite from the center of Earth. Now, what is formula for kinetic energy? Kinetic energy is half m v naught square. So this will be equal to half m. V naught square is Gme upon r. So if you rearrange this term, this will be equal to half of Gme upon r. Let this be equation number 1. Also, the potential energy of this satellite is, formula for potential energy is V is equal to minus G MEM upon R. We have already discussed this, minus G MEM upon R. Hence, the total energy of satellite will be, hence, the total energy of this satellite will be E is equal to kinetic energy plus potential energy. So your kinetic energy is half of G MEM upon R minus G MEM upon R. So this is G MEM upon R, half of G MEM upon R minus G MEM upon R. So half minus 1 will be minus half. So this will be equal to minus of half G MEM upon R. This is the total energy of orbiting satellite. Right. Total energy is negative, which indicates that this satellite is bound to Earth's gravitational field. Negative sign always indicate the bound state. So here this satellite is bound to Earth's gravitational field by this energy. That is, if you supply plus half of GMEM upon R amount of energy to this satellite, it will escape from Earth's gravitational field, right? Here R you can replace by Re plus H. Re plus H. Now, if satellite is very close to the surface of Earth in such a way that we can neglect H, so in that case R will be equal to Re. So the formula will be minus half G MEM upon Re. Clear? Now, if you see this, let this be equation number 2 and this be equation number 3. So from equation 1, 2 and 3 you can say that, look, here kinetic energy is half G MEM upon R and total energy is minus half G MEM upon R. So you can say that if kinetic energy equal to X, if we take kinetic energy equal to X, then total energy will be minus X. Total energy will be minus X. Now if you multiply this by 2, you will get this, right? If you multiply by 2, then half will get cancelled out and G MEM upon R with negative sign, so G MEM upon R with negative sign. So if kinetic energy is X, then total energy will be minus X and potential energy will be minus of 2x. Look, this is the most important concept for solving MCQs. It might be given in your exam that the kinetic energy of a satellite is 7 into 10 to the power something, like let us say 7 into 10 to the power 4 joule. Then find its potential energy and total energy. Nothing else will be given. So kinetic energy is 7 into 10 to the power 4 joule. then total energy will be minus 7 into 10 to the power 4 joule, and potential energy will be minus 14 into 10 to the power 4 joule. Clear? So this is the topic related to total energy of orbiting satellite. Okay, thank you.